Welcome to Daily Papers, the podcast where we break down the latest and greatest research into bite-sized pieces.
Today, we're diving into a question that's on a lot of people's minds. Can AI actually write good computer code? We all hear about tools like ChatGPT and Copilot, and apparently over two-thirds of professional developers are already using them.
But there's a catch. Some reports are showing a big increase in something called code churn. That's a fancy term for when newly written code gets deleted or replaced very quickly. It's like hiring a builder who does a job so poorly you have to rip it all out a week later.
Exactly, which raises the question, are these AI tools helping us build better software, or are they just helping us create junk code faster?
Well, a new paper titled Holistic Evaluation of State-of-the-Art LLMs for Code Generation decided to find out. Researchers essentially created a coding Olympics for 6 of the world's top AI models.
So who were the contestants in this AI Olympics?
The lineup included some big names you might recognize, like GPT-4 and Claude 3.7, alongside some highly specialized models built just for coding, like one called DeepSeek R1. It was a mix of general-purpose geniuses and coding specialists.
And what was the event? What challenges did they have to face?
They were put through the ringer on a platform called LeetCode. If you're not in the tech world, LeetCode is like a gym for programmers. It's full of thousands of coding puzzles that companies use to test developers in job interviews.
So these aren't easy hello world type problems. These are real tricky challenges.
Absolutely. The researchers took nearly 1,000 of these problems, spanning 5 different programming languages, like Python, Java, and C++, and gave them to each AI. Just one shot per problem, no do-overs.
Okay, so how do you even score an AI in a coding competition? What are the judges looking for?
This is where the holistic part of the title comes in. They didn't just check if the code worked, they measured performance across 5 key areas.
Let me guess. The first one is just, did it solve the problem correctly on the first try?
You got it. That's the main metric, called pass at 1. But then they looked at the failures. First, were there compile time errors? This is like writing an email with so many typos and grammar mistakes that the computer can't even understand what you're trying to say.
Okay, what's next?
Runtime errors. This is when the code starts to run, but then crashes halfway through. It's like trying to divide by 0. The program just gives up.
That sounds bad.
It is. Then there are functional failures. The code runs perfectly, it doesn't crash, but it gives you the wrong answer. The logic is just flawed.
And the last one?
This one's my favorite, algorithmic suboptimality. This means the AI solved the problem, but in the slowest, most inefficient way imaginable. It's like being asked for directions to the grocery store and giving a route that goes through 3 different cities. It technically works, but it's a terrible solution.
So the results. After this massive AI showdown, who came out on top?
The gold medals went to 2 models, DeepSeek R1 and GPT 4.1. They were consistently the best across the board. They wrote code that was correct, robust, and efficient most of the time.
And what about the models that struggled? Where did they go wrong?
The biggest issue for some, like a model called Llama 3.3, was that last metric we talked about, efficiency. It often produced code that worked but was just too slow to pass the time limits on LeetCode. It was constantly taking the scenic route.
That's fascinating. So it's not just about being right, it's about being smart and efficient in how you get to the right answer.
Precisely. They also found that the programming language made a huge difference. The AIs had a much easier time with Python and JavaScript. They made very few basic grammatical mistakes.
Why is that?
Because those languages have a more forgiving and flexible syntax. It's like having a casual conversation. But languages like C++ and Go are much stricter, with more rigid rules, almost like writing a legal document. The AIs stumbled over those strict rules more often.
So the tool is only as good as the context it's used in. But the researchers also tested something else, right? About how you ask the AI for help?
Yes, and this might be the most practical finding. For one set of tests, they added a simple 7-word instruction to their prompt. Optimize the time complexity of your algorithm.
which is basically just telling the AI, hey, please do this efficiently. Don't take the scenic route.
Exactly, and it worked wonders. For most of the models, that simple hint significantly reduced the number of slow, inefficient solutions. It proves that being very clear and explicit with your instructions is critical to getting a good result from an AI.
So what's the big takeaway here? Are human programmers going to be replaced by these AI models anytime soon?
Not a chance. The paper makes it very clear that even the best models, the gold medalists, still fail sometimes. They miss tricky edge cases or make logical errors.
So the AI is more like a junior assistant than a senior engineer.
That's the perfect way to put it. It's an incredible tool for generating a first draft of code. It can save developers tons of time, but you absolutely need a human expert to review, test, and refine that code.
It reminds me of a quote from the paper, that intelligence amplification is greater than artificial intelligence. The goal isn't to replace human intelligence, but to augment it, to make the human programmer even better.
I love that. So the final verdict from this AI coding Olympics is that while the contestants are getting incredibly skilled, they're not ready to compete without a human coach in their corner.
A great reminder that for now, the most important component in software development is still the person sitting at the keyboard.
That's all for today on Daily Papers.